Welcome one and all to the lesson on linear trig equations, where you will learn to solve these types of equations. In order to get started, however, we do need to review back to several previous topics, one of them being the inverse trig functions. Remember that the inverse trig functions are the opposites of trig functions, where your goal is to actually find the missing angle given the value to the problem. Now, this is just a simple matter of taking a calculator, such as Desmos, using the inverse trig function, put in the value inside the parentheses to that function, and then you can find the angle, as long as you have the correct settings set up so that you can either find the degrees or the radians. The next thing we need to take note of is there are 4 unique angles, to an extent 5, that you need to be aware of for these problems. The 0, 90, 180, 270, 360 degrees have unique answers that you can easily find by using this chart. Now, the difference is that you will be given the values, you need to match it with the correct trig function, and then you can find which degrees was originally used for that problem. So these are the unique angles that you can easily find using this chart. This does not work for every problem, but it is to make your life a lot easier in the future for certain problems. We also need to recall back to the signs of the trig functions. So depending on what answer you find in the problem will help you determine which quadrants your angles should be. And this is going to be important for certain problems, because if they're not quadrantal angles, it will fall between these 4 quadrants. So using the acronym ASTC is going to be very important for remembering, hey, this quadrant should be positive for only sine, so that would be the second quadrant. This trig function tangent is only positive in the 3rd quadrant, and cosine is positive in the 4th quadrant. And don't forget that everything is always positive in the 1st quadrant. So that should be easy to remember. That's all. And the order should help you determine which is which. Now, this will tie in with reference angles, because before, when I introduced this lesson, reference angles is what you found. Here, you're going to be given reference angles to find the original. Now, quadrant 1 is very easy. If you find the reference angle and you know it's in quadrant 1, it's equal to your standard angle. Here in the second quadrant, however, you need to actually take the reference angle, subtract it from 180 to get the original angle to the problem that we are asked to solve for. So this is the formula you really need, the one boxed in pink. The one above was what was first introduced when you learned about finding reference angles given the original angle. So we're going backwards instead. We're going to find the standard angle by substituting the reference angle into this formula. So here's the formula for the 3rd quadrant, where you have 180 plus the reference angle to get your original angle. And the last one is the 4th quadrant, where the standard angle is equal to 360 minus the reference. So tying it in with the signs of the trig functions will tell you which quadrant you're focusing on, and that will tell you which formula you're going to use. So here's our first example. You have this problem that says find all angles between 0 and 360. So in other words, you will have answers that range between 0 answers, 1 answer, or 2 answers. Those are your 3 options. And you're not just going to determine how many answers you have, you're actually going to solve for them. So here's the original problem. You have 8 sine b plus 1 equals sine b plus 1. So to make your life easier, what we're going to do is we're actually going to replace sine b with the variable x. Okay? The reason why we want to do that is because it helps us know what we should be solving for. We're trying to solve for sine b. In other words, we're now going to solve for x. We want to get x by itself. This is a multi-step equation now. So the first thing you want to do is you want to subtract x on both sides to move everything to the left side. That gives you now 7x plus 1 equals 0. Now what we want to do is we are going to scroll down, and now the next step is to subtract 1 on both sides, so that when you do that, you get 7x equals 0, And the last step would be to divide both sides by 7 in order to get 0. So don't forget that x is really sine b. So that's the only tricky part you need to remember, is that if you were to replace sine b with the variable, you got to switch it back once you get x by itself. So currently we have sine b equals 0. And you can apply the inverse trig function here at this point. And that will help you solve for b. That will give you the answer. The only downside with this is that if you were to put this in the calculator, it would only give you one of two options. So this is why having that quadrantal angles chart is going to be really useful. So I'm going to pull this up right here. I'm going to highlight in green what we know. We have the sine function, and we're told that we have the values of 0 here, here, and here. So you actually have three options. Our three answers are, because the goal is to find the degrees, the angles. So we have 0 degrees, 180 degrees, and 360. Well, we don't actually need to use 360 because 360 is the same placement as the 0 degrees, and there's no need to repeat the same number. We're just going to use the two ones we really need. So it's going to be 0, 1, 80. So that's why when we do the work, this is all you'll really see. They don't really show you that chart. They just expect you to remember the quadrantal angle 0 degrees and 180 degrees has the value of 0 if you were to take the trig function of sine for both of these. Okay, so that's where using the chart is going to be really useful. If any of your trig functions, sine, cosine, or tangent, is equal to one of these values on this chart, then you can use this chart to find what degrees matches that. And if you have 3, it's really just 2. It's just remember these 360 and 0 are the same answers, so you want to use 0. And that makes sense with what they said in the degrees. Up here, it's going to be 0 less than or equal to b, but less than 360, so not including 360. So therefore, 0 and 180. So that's our answer for this problem. So skip that. All right, so here is our second example. So this one's not going to use the quadrantal angles chart. We're going to have a different value, which you'll see. So here we go. We find the same boundaries between 0 and 360. We have to round to the 10th if necessary, and here's our problem. First thing that we do in this problem, just like what we did in the previous problem, is we want to replace the cosine function with x, so that when we finish solving for x, we can replace it with cosine theta. So they subtract 5x on both sides to move everything to the left side. So you have negative 3x minus 3 equals negative 5. Add 3 on both sides to get negative 3x by itself. So that's now negative 3x equals negative 2. Divide both sides by negative 3. And a negative 2 divided by negative 3 reduces itself to positive 2 over 3. And now we can replace x with cosine again. So there is our trig function isolated by itself equal to a value. Now our goal again is to find the angle, so we're going to use the inverse cosine function, because the 2/3 is not part of our chart. You don't see 2/3 anywhere on this chart. It's not in one of our values. So we come back up here, and the first thing we want to identify is cosine positive or negative, because that is really important. This is where we need to determine, using the ASTC acronym, we need to determine which quadrant is our angle going to be in. So because we're positive 2/3, we know, using the ASTC acronym, cosine is positive in A, which is quadrant 1. But cosine is also positive in the 4th quadrant. So those are our two quadrants that we're going to focus on. So now we apply we're going to find the reference angle by applying the inverse cosine function. So this is where you go to your Desmos calculator or your graphing calculator. Make sure that you set it to find degrees, not radians. Please make sure you check, okay? I even pull it up myself. Make sure you check that your degrees is what you're highlighted for the Desmos or in your graphing calculator. So you do the inverse cosine function of 2/3, you get 48.19. We're going to round it to the 10th place, so it's going to round up to 48.2. Because we determined that cosine is both in the first quadrant and the first quadrant and the fourth quadrant, we're going to apply the reference angle formula that I showed you earlier. So now the first angle is going to be really easy. If your angle is in the first quadrant, your reference angle is the answer to the first quadrant. So it's going to be 48.2. That's one of your answers. However, if we were to find it in the fourth quadrant, remember the formula I gave you on the slide before, you have 360 minus 48.2, and that gives you 311.8. So those two values are our final answer to this problem. Okay, we have 48.2 for the first quadrant and 311.8 for the second quadrant, or for the fourth quadrant, for the second answer, I should say. All right, here's our last example. So this time we have a trig function equation. We have a square root involved, but the steps are exactly the same. You first replace any trig function you have with the value of x. You get that by itself by subtracting square root of both sides. So you have 3x equals negative square root of 8. Divide both sides by 3, and x is equal to square root of 8 over 3, and it's negative. And we change it back to tangent c. So we've successfully isolated the tangent function. Now, do you have to replace it with x? No, you don't have to. You can just go straight to just solving with these steps and keeping it tan c, but replacing it with x makes it easier and it's a lot more obvious about what you're solving for. Alright, so we have successfully found our trig function value to tangent, but in order to find c, we first need to determine which quadrants would the tangent of negative square root of 8 over 3 belong to. So you scroll back up, and we notice that tangent c is negative. So again, a smart trig class. See, even I use it. And this is where you have to remember that tangent is negative. So in other words, we have to pick the areas that are not positive. So if it's positive in if it's positive in the all quadrant and tangent quadrant, we want to pick the one where it's negative. So in fact, we're going to pick the second quadrant and the fourth quadrant, the S and C, because that's where only sine and cosine are positive in those, so that means everything else is negative. So it's going to be quadrants 2 and 4. So we find the reference angle now by using the inverse tangent function. So we put this in our calculator. Again, make sure it's in decimal setting to degrees. 43.314, round it, keep it to 43.3. Scroll down, so now we have all the key pieces of information. We know it's in the second quadrant and fourth quadrant. We know that the reference angle is 43.3. Now we're going to use the reference angle formula to find the original angle. So you take 180 minus 43.3, and that gives you the second quadrant angle, which is 136.7. And the fourth quadrant is 360 minus 43.3, and that gives us 316.7. And those are the two answers to this problem for the second quadrant and the fourth quadrant. And that's all there is to it with the trig equation. So there are a lot of components to these problems. Please make sure you carefully walk through each step, see how it relates to the notes that I shared earlier in the beginning of this video, and just try to look at each example I've covered in the Desmos assignment. There's going to be multiple, these are the only 3 types of problems that you'll see with these problems. So, good luck.